Now there's one other example I'd like to walk through with list comprehension because there's one other alternative formatting method and alternative syntax for list comprehension that is sometimes useful to us. And it differs slightly from what we saw in the previous video, but involves making combinations of lists, loops, and branching statements. So one of the homework assignments that we've done recently is to implement a Caesar cipher, where we're going to associate them with their position in the alphabet. And you can see that I've created an object for doing that right here, a Python dictionary object that has as its keys the lowercase letters of the alphabet, and then the value that corresponds to that key is its numerical place in the alphabet. What we do after associating that letter to a number is we perform a shift on those numbers, adding or subtracting a particular value to shift the value that we're looking at, and then we do a reverse lookup of taking that number and determining the letter that goes along with it. So that's just an overview of a problem that I'd like to re-examine with this alternative list comprehension syntax. So far in my Python code, I've created this dictionary to help look up the numerical values for the letters of the alphabet. Then here in line 5, I prompt the user to enter a particular text to encrypt. Typically, any message that we would like to encrypt is going to have spaces in it in between the words. And I don't think that we want to encode the space. We want to preserve where the spaces are in order to help with readability. So if the user enters in a lowercase letter value, we want to use this dictionary to look up a number to go along with it. However, if the user enters a space, we don't want to ignore it, we want to preserve it, in fact. So what we can do is come up with a syntax for list comprehension that actually puts two different things into the list based on whether or not a conditional statement is true about the value that is encountered. And I'd like to show that to you today. So far we've discussed lines 1 and 5. Line 1 is that Python dictionary. Line 5 is where we prompt the user to enter their text. What I've done in line 3 is I've used one of my dictionary's methods, which is to access its keys, and I've asked my dictionary to give me its collection of keys so that I can store them in this object right here that I've named my keys. I'd also like to discuss line 7. Line 7 is just a shorthand. I don't know what the user is going to enter for their original text, but that text that they enter is going to have a certain number of little characters in it, the length of a word, say. And so what I'm doing is calling this length function on the user's input to know just how many letters of the alphabet or spaces they might have entered in. So let me demonstrate this list comprehension notation for you. Let's say that I want to do that process now of going to letters to numbers and looking up the numerical value that I need to associate with a lowercase letter, but I only want to do that if the letter that I've come across happens to be a key of the dictionary. If I attempt to look up a space in my letters to numbers dictionary, Python's going to give me an error saying I can't access that because that's not a key, and so I don't know what output value you want. For example, if I tried to print to the screen letters to numbers of a space, Python gives me this error, and it says key error, space. In other words, space is not a key, and so it doesn't know where to go to look up that thing. When I create my list, let's call it text as numbers. I give my new list a name. I use my assignment operator and my square brackets. And the first thing I need to enter is the expression. The expression that I want is I'd like to go to my original text. I'd like to iterate through my original text. And at position I of my original text, that should hopefully be a lowercase letter. I'd like to go to letters to numbers and look up that particular key. So what I would like to put in my text to numbers is the value of the letters to numbers object, and the key that I'd like to pass it is original text at position I. However, I would only like to do that if original text at I belongs to my keys. So that's the very next thing I write. I'm going to put my conditional here. If original text at I is in my keys. I will now specify what to do if that condition fails by using the keyword else. What do I want to do if I fail this condition? Then what I'm going to do is put in the number 99. I'm just going to pick a number to add to my text to numbers list in the event that this fails. And the fact that this value is larger than 25 will serve as an automatic reminder to me that that's a space, and I shouldn't bother doing any translation with that. So I've done the first part of my list comprehension. You can see that Python is angry with me because I haven't finished the syntax that I need. Here I've done my expressions in the plural, and now I need to do my member and my iterator. So my variable that I'm using is I, and I'm iterating over the length of the original text, which I'm using the variable length to represent just how long I'm going to have to go in here. If I now add in a few lines of code to do a print statement, we can watch to see if this code has the effect that we would like it to have. So let's enter the message hello world with a space in between, and when we hit enter, we get numerical values for H, E, L, L, O, and then where I entered that space, I have a value of 99. And then I return to using my dictionary for W, O, R, L, D. So just to go over that last syntax that we'll study for list comprehension more completely, the syntax is as follows. The name of our list goes over here on the left, followed by an assignment operator, and then we encase something in square brackets. What we encase is the first expression we would like to put into our list, and that's the expression we would like to put into our list if this first conditional holds. However, if this first conditional is false, we use this Python reserved word else, and then we can change the expression that we want to appear in the list. And so we add this if-else branch, not at the end of the list, but at the beginning, because we want to change the expression that goes into the list based on the conditional. The remaining syntax for member in iterable is exactly the same as it was in our previous studies of list comprehension. Now this begs the question, if I can have an if-else and put in two different expressions at the first part of my list, then could I use an if-elif else in my list comprehension as well? There's a little bit of interesting history there, but there is a way in order for us to do this. Weirdly, it doesn't involve the elif reserve word, but just the else reserve word twice, and it is purposely meant to be complicated and confusing in order to discourage users from using this. I think at this point in time, especially when list comprehension is new, this amount of syntax just to do something in one line is starting to look a little bit overwhelming, and the simplicity that we've gained from list comprehension is beginning to get lost. And although writing out for loops with branches inside the for loops takes up more vertical space in your Python code, if doing that is more self-explanatory and takes things a little slower and one at a time, then that's what's going to make your code more readable, and that is far superior to saving space within your Python document. So there is a way that you can do this and extend it past just an if-else statement into as many nested conditionals as you might like, but it's not particularly desirable. And if you find that you're trying to go that far with list comprehension, it may be best just to take things a little slower and use a couple more lines of code to do it and make sure you've done it right.